All right, let's take a look at section 1.4. There's a couple of problems I want to do. One is just a mechanical process like this one here. The next video is going to have an application. This, you know, so you may or may not have been taught this in Calc 1 or Calc 2, I should say, and that's okay. We'll go over it again. This one says find the particular solution to this differential equation. There it is, right? And so what we have in sections 1.4 and 1.5 is, can I separate the variables so that I can integrate both sides, like i.e. it's a separable differential equation, or is it non-separable but linear, in which case I have to, in section 5, I have to use the integrating factor. So never done this before. Here's how it goes. Okay, I picked this problem for fun. It's handpicked by me. So what we want to do, what I'm going to try to do is separate the variables so that I have some sort of like function of y times its differential dy, and on the other side I'll have another function of x by itself times its differential. If you can get your integral in this form, your equation I should say in this form, then you are allowed to integrate both sides. So in other words, you're at the derivative level, separate, integrate to the function level, and you're on your way to solving the problem. So that's what we're going to do. We're going to, here's how you do it. What I'm going to do at the front end of this is pure algebra. Can I get it in this form, question mark? What I'll do is I'll throw the y to the other side as, say, I'll write it as 2x squared y, no, y, y, and then plus y. Okay, and then I'll get rid of the x, I'll divide it out, and I'll just go, okay, so dy dx is equal to, now the algebra I'm going to do quick. What I'm going to do is divide the x, but I'm also going to factor out the y. If I factor out the y, I'm left with 2x squared plus 1, and then there's y, but then I scoot the x underneath, and what I've done is nothing but algebra, okay? Nothing but. What I'll do next is I'll send the y to the other side, and I'll write dy, and the dx, the differential dx, I'll multiply to the other side, and I'm left with 2x squared plus 1 over x dx, and we've done it. The guys are separated, okay? So that was just algebra, but the thing that you may or may not have seen, I hope you have, is the differential dy dx splits into, here's dy, and over here we multiply the dx, and these are differential equations right here, okay? There you go. Okay, just like we're solving, huh? So we're ready to integrate. That's the next step. So we're going to integrate both sides, each side. One is a function of y, the other is a function of x. Okay, the function of y, not hard. What I'll do right now is I'll assume that y is positive. So I'm going to assume that y is greater than 0. This is where you get into this world of differential equations where I find the function, but where is it defined and what part of the domain are we really speaking? So right now I'll keep it simple and I'll just simply say, hey, I'm getting the natural log of y. So I don't have to worry about absolute values right now if I make that assumption. The other side, you guys, okay, I always trip up Calc 1 students with this one, and we really shouldn't be. You're really looking at the integral of 2x plus 1 over x dx. I just split the powers, and I'm integrating, so we get the natural log of y is x squared plus the natural log of x. Okay, now I'm going to assume that x is greater than 0 for this problem. Okay, and then we are going to, the all-important plus c on that side. Okay, so again, algebraically, wrote it in separate form, moved the differentials where they belong, dx on this side, dy on this side. We're integrating. We are at the function level now. Once we've integrated, we've elevated from, say, velocity to position, if you will. That's what we're doing. Okay, we have a particular solution we're looking for. I like to use this guy. When they say that y of 1 equals 1, that means when x is 1, y is 1, and it has to be, that has to be satisfied. So what I'll do is I'll go ahead and put the 1 in for y, the 1 in for x, okay? And we've got natural log of 1 now instead of y is equal to 1 squared plus the natural log of 1 again plus c. Okay? For our general solution to solve this, go through that 1.11, then c is forced to be a particular number. Okay, so natural log of 1 is 0. 1 squared is 1 plus natural log of 0 again is 0. 1 is 0. And so we get, oh, look at this. C is equal to -1. So go back to your equation then. Natural log of y is equal to x squared plus the natural log of x, and then -1. And I like you to solve for y if you can, and we're going to do it right now. I'm going to say e and e, okay? So cancel, we have y is equal to this thing, e to the x squared plus ln x minus 1, which will give you an a. That's good. But I like to clean it up sometimes. So what I've got is e to the x squared, e to the natural log of x, e to the -1 because of the power rules, right? Pause and think about it. And so my answer looks a little bit cooler because this thing here, e to the natural log, all of that is x. So I'm getting x e to the x squared take away 1. That looks cool. You know what? They're both good. I'll give you credit for either one of those answers, of course. And that's how you separate, integrate, find C, write your final answer, okay? So those are good problems to do, and have fun with those. All right, I'm going to come up with an application next.